Thank you so much. Sound levels okay at the back? Excellent. Right. So in my talk, I'm going to introduce you to a few good friends of mine. They are volcanoes. Some of them are from Iceland, like myself, and some others will be from Central America and Hawaii. But I'll start off my talk by explaining a little bit, why are we worried about air pollution from volcanoes? Why is it not just ash that we need to worry about? And then I'll use some examples. So I'll introduce you to some volcanoes, which I call the killer fog generators. So these are very large, sort of catastrophic events that can have impacts across the whole hemisphere. And on the other hand, we're going to have the annoying neighbors. So these are volcanoes that are perhaps not as dramatic as the killer fog generators, but they are active for very long periods of time. So you can spend your whole life living with this annoying neighbor. So how many people here remember what happened in 2010? Yeah, quite a few. So we had this eruption. I can pronounce the volcano name. There you go, Eyjafjallajökull. There we go. And of course, it grounded all the aircraft. People couldn't go on holidays. It was a disaster. And every time a volcano shows unrest in Iceland, the media really jumps on that bandwagon and is like, it's going to be the end of the world. It's going to be, we can't go on holidays ever again. And I wouldn't blame people for thinking that that's what happens every time a volcano erupts in Iceland. But that is actually absolutely not the case. Eruptions happen in Iceland every 3 or 4 years on average, and actually the eruption frequency is going up. And have you had disruptions since 2010? Not really. Maybe tiny disruptions here and there, but nothing to write about in the Daily Mail. And actually, if we look at what eruptions have killed people in Iceland's past, something very interesting will come up. So remember, eruptions happen every 3 years on average, let's say. But we only have 9 eruptions in the last 500 years that we know that have killed people. So let's look at how many people have died and what they died from. The one person died of impact injuries, so they're getting hit on the head. Where's the meteorite rock? Something similar to Alan's rock over there. A few more have drowned in so-called jökullhlaups. Jökullhlaup is an Icelandic word, but it's now used actually around the world. It's a flash flood when volcanoes erupt underneath glaciers. They are very hazardous things, move very quickly. There are a few more weird fatalities. One person got struck by lightning, one scientist got killed by lava, and one person went into a basement. The basement had been filled with carbon dioxide, and he drowned in that carbon dioxide. He was actually trying to loot the house. But there's one eruption there, Laki, in 1783 to 84, which I haven't put up. Let's have a look at that one. Quarter of Iceland's population died at the time. But the really remarkable thing here is that it didn't kill anyone directly. Nobody got hit on the head. Nobody drowned. This eruption, it caused such huge environmental and air pollution that 90% of the livestock perished. And as you can imagine, that caused famine. It caused epidemics, general ill health, and yeah, a quarter of Iceland's population was lost. So how do volcanoes induce this huge environmental and air pollution? Well, they emit these clouds of gases and aerosols into the atmosphere, and we refer to them as plumes, so that I'm going to be calling them plumes from now on. And if we draw this as a cartoon, so these plumes, they're very rich in gases and aerosols, and where they get deposited, so either they can just kind of drop down from the sky, or they can get washed out by rain, and the rain becomes very acidic, they can start to impact the environment, health, property, plants, you name it. And why? That's because volcanoes, they're kind of recycling stations of the Earth. They emit almost every naturally occurring element. And some of those, a lot of those, are quite toxic. Volcanic gases, they contain a lot of things. And one of the most important gases is sulfur dioxide. Very, very nasty chemical. In high concentrations, it will kill you. Low concentrations, it will give you respiratory problems. Hydrogen chloride, hydrogen fluoride, again, very nasty things that you don't want to be breathing in, either at high or low levels. And then we have the plumes, they're also full of these aerosol particles. And aerosol particles, you can think of them as dust suspended in the air, very, very fine things. So Chris earlier was trying to impress you with his wasp. He said it was something like half a width of human hair or something like that. Well, my aerosol particles, you can fit 100 up to 1,000 into a width of a human hair. So imagine breathing them in. They will go all the way through your lungs, into your blood. They can even cross the brain barrier, which is hard to do. And in volcanic plumes, they tend to be very, very acidic. We get a lot of acid rain around volcanoes with pH about 2. So let's look at some examples, the killer fog generators. So the Laki eruption in Iceland in the late 18th century is a very good example. And luckily for us, they are generally rare events. They happen every few hundreds of years in Iceland, but they can have a huge impact when they do happen. Now, I tried to find a video of Laki eruption on the internet. I didn't succeed. It's like they didn't have video in the 18th century. But I did have this footage from Hawaii. So the Laki eruption would have looked very similar to this, only much bigger. So you have this beautiful red lava flows oozing out of the volcano. And then you have this cloud, this plume coming up. And you can see it's white. If we would have ash in it, it would be much darker. It would be black. But instead, it's white. But if you can see, it has this very specific blue, sometimes brown tinge to it. This is very indicative of plumes that are very rich in sulfur dioxide gas and a lot of aerosol particles. And the Laki eruption lasted 8 months, and it would have filled nearly 6 million Olympic swimming pools of lava. And let's now look at how much gas came out of it. This is how much sulfur dioxide the UK produces in 1 year nowadays. Back in the 1950s, 60s, 70s, it produced a lot more because we used to burn a lot more coal. So if you think of the pea soup smog events in London or other big cities, that's what was caused by sulfur dioxide. This is how much Laki produced. So can you imagine living next to that volcano at the time? It would not have been very nice at all. And of course, Laki not only impacted Iceland, it was so big that the sulfur-rich fog spread across Europe. It spread into Russia, Northern America, so all around Northern Hemisphere. The red circle shown there on the globe is where we have written records that people noticing the sulfur-rich fog. And people, when they wrote about it, they all typically described this as dry fog, and it started to cause crop failures all around Europe. Here's a London newspaper that was published at the time of the eruption, and this is how they describe it. For some time past, we have had excessive hot weather, and the sky is constantly covered with a thick fog, which, without totally intercepting the sun, deprives us of its brightness. Far from moistening the ground, this fog dries up the grass in the fields and the leaves which drop off the trees, most of which are now left bare. But look at the date, it's in August. So imagining everything just drying up and dying in front of your eyes in the middle of summer. That's pretty weird. And people, of course, at the time wouldn't have known that it was coming from some volcano in Iceland. So it would have been a really bizarre experience, and people would not have been prepared. There is also evidence that mortality not only increased in Iceland, but also in the UK and probably in other European countries. Again, going back to the newspapers, it says, the season for months past has not been healthy. The bills of mortality have increased prodigiously. This must be taken with a bit of a pinch of salt because it's very difficult to untangle what people died from 200 years ago. Health records were just not very good. So we know that the Laki eruption had huge impacts in Europe, but how exactly it impacted the environment and people's health, it's very difficult to say exactly. But luckily for scientists, 4 years ago, a very similar eruption started up in Iceland. It was very similar to Laki in the sense that it produced lava, it didn't produce any ash, but pumped out a lot of these gases. But then luckily for everybody else involved, it was only 1/10 of its size. So the air pollution was not as bad as during the Laki event. But nevertheless, it produced repeated and really serious air pollution events in Iceland. And actually, it reached Ireland and the UK as well. And this is how people in Iceland described it. Couldn't see the hills because of the blue mist eyes itching and stinging, runny nose, throat and nose burning, saw bluish mist, very smelly, made me nauseous. And not surprising, because sulfur dioxide concentrations were reaching levels that are considered dangerous, and that's at hundreds or more miles away from the volcano. We did a big study, and we discovered so many things about this eruption that we didn't know before, showing how important scientific opportunity this was. Because we knew that the Laki eruption in the 18th century, killed all these people, devastated so many things, but we knew so little about it. So this was such an important opportunity to actually see this volcano and being able to apply all our modern science on it. What we saw, and we didn't know this before this eruption happened, is how the plume really moves around. This animation shows the volcanic plume leaving Iceland, and you can see it travels towards Europe, and then it kind of swirls around Europe, and on occasions, it comes right back and washes again over Iceland. So this was important finding because in Iceland, they used to issue public advisories saying the air quality is going to be really bad today, so please, people who are going to be sensitive to it, people with asthma, you can take measures like staying indoors, not exercising outside, and things like that. But people didn't know that the plume could go all the way out to Europe, swirl around, and then come back for a second hit. There were no public advisories issued for that kind of air pollution. And it reminded us very much of a boomerang. We started calling it a plumerang. So we looked at health records to see if that plumerang effect actually also had health impacts. And yes, we did see that. We saw an increase in anti-asthma medication. We saw GP visits increasing and even hospital emergency admissions. And actually, the increase was highest for children. And it shows the importance of being able to predict these kind of events accurately because, for instance, in Iceland, it's very common practice to let babies and small children sleep outside in prams during the day. And in the winter, all kinds of weather, your Vikings, yeah, kind of. But if parents had known about this air pollution events coming, they could have taken a very simple measure of not putting their kids out in the pram that day. But enough of the these killer fog generators. Let's look at much more subdued types of volcanoes, the annoying neighbors. So moving away from Iceland, I'm going to take you to Central America. There is a country called Nicaragua, and in Nicaragua is a volcano called Masaya. And Masaya is a very special volcano. It has been active, again, not producing any ash or lava, but pumping out gas for over 500 years, probably more. That's just as far as written records go. And it goes through periods of very high gas emissions with beautiful red lava lake there on the top, and sometimes it's very low with just a few wisps of smoke. And it produces that beautiful volcanic plume that you saw earlier. And we actually have been working out there and not really looking at the volcano itself. We've been looking at what is it like for people to live with it. What is it like being this volcano's neighbor? And we made a short documentary, and I want to show you the first minute of it. So this is people living on the volcano telling in their own words, what is it like? It's in Spanish, but there are subtitles.
Yo vine aquí de 25 años. Aquí compramos este lugar, pero no hacía daño el volcán.
Estamos en la comunidad Panamá Los Amadores, una comunidad que es bastante afectada por lo que hace volcánico. Tengo de vivir aquí 17 años. De nuestros 17 años pues he tenido experiencia de cómo el volcán nos afecta, cuál tenemos el cuidado que tenemos que tener, cuál es lo que tenemos que hacer, ¿verdad?, en estos tiempos de lluvia, que sabemos que cuando más se alborota el humo.
the people you saw in the film, they live only 1 mile away from that active crater. And if you go there, you don't even have to be a volcanologist or any other kind of scientist, really. You can see it with your bare eyes, how the volcano impacts people's everyday lives. For instance, metal rusts really, really quickly because of all the acid coming from the volcano. And you see that really rusty metal cabinet. Things can get to that state within a matter of days, even when they're indoors. And that means that people have had to adapt, and they've learned even to build their houses without using any nails. And the woman in the film, she later goes on to say that even if you wear earrings, your skin will become completely covered by rust after a couple of days. The gas just gets everywhere. And another very important impact is that vegetation survives really badly in areas impacted by volcanoes. Masaya is a tropical country. The vegetation there should be a tropical forest, but instead it's reduced to really just yellowed scrubland. And what that means for the people is that they can't grow their basic food crops. In Nicaragua, you usually use subsistence farms, so it means you eat what you grow yourself. And there, people usually grow rice and beans, but people living on this volcano can't do that, so they have to turn to other sources of income. And also, coffee, which is Nicaragua's largest export product, what the economy really hangs on, is very, very sensitive to volcanic emissions. And we found one report from the 1940s which talks about this astronomical sum at a time, $10 million US, being lost when the volcano started up again. So imagine for a country, developing country like Nicaragua, that is a huge, huge blow. And the government of Nicaragua has been very concerned about this volcano, and it's really fun to go through all kinds of documents and look at what they have done in the past. They were not particularly worried about the people living on the volcano. In fact, they don't mention health impacts at all. Well, actually, I lie. There is one report that mentioned health impacts, but they say very specifically, there is no bad health effects from this volcano. It's fine to go and toil in the fields and grow our coffee there. It's all fine. But they were very concerned with the coffee itself. In the 1920s, they introduced a special anti-volcano tax to pay for their schemes. So let's have a look. In the 1920s, they were going to build a big funnel. They were going to put that over the top of the volcano and siphon the gas away. And they didn't lack ambition. They were not just going to release the gas somewhere where it doesn't cause any problems. They were going to collect that sulfur and sell it commercially. It did not work anymore at all. Then in the 1950s, they were going to release another chemical on the volcano, and that chemical was going to react with the chemicals coming out of the volcano, and it was going to fertilize the coffee, and again, it didn't work. And then there were multiple attempts to bomb the volcano. And this photograph there is a letter that President Somoza, who was a dictator of Nicaragua, he wrote to the US Air Force to ask them to drop a nuclear bomb. Yeah, and they didn't nuke the volcano, but they did drop a regular bomb, I think more than once, and it didn't do absolutely anything to the volcano. And then it's really, really interesting to contrast these highly engineered, really sci-fi government schemes with what the local communities are doing themselves. Several decades ago, farmers started collecting fruit that was growing wildly on the volcano. It's called pitaya, or dragon fruit. And because this fruit was already evolved to living on this volcano, of course, it was very beautifully adapted to being cultivated, and actually kick-started the local industry, local export. And that's what people live off there when they can't grow their basic crops. And pineapple is another crop that grows really, really well on the volcano. People tell us they don't even use fertilizer. Why that is, nobody has yet researched. I think it's a hugely important area to understand. Can we, for instance, cross coffee with pineapple? Create a highly resilient crop. If you have any ideas, any avid gardeners, please let me know. But essentially, I would like to summarize what I've said, that volcanic air pollution and environmental pollution can have really serious impacts. And that can happen both as a sudden onset disaster, like the killer fog generators, or they can have these long-lived chronic hazards. We can't stop this volcanic air pollution. We do not yet have the technology of fitting an air filter or sending a chimney sweeper down a volcano, but we can prevent them from becoming disasters. And simple solutions can often be much more effective than very high-tech engineered solutions, especially if those high-tech solutions are not grounded in reality and they do not take into account what's needed right here and now. So our film, if you're interested in watching the rest of it, is available through YouTube if there are no solar flares. Thank you very much.
Thank you very much, Evgenia. That was fantastic. Does anyone want to kickstart the questions? Like, it's not that frequently you're going to get to ask a volcanologist something. Does anybody want to kick off? Or will I go first? I'll let you think for a second. Someone who had to leave at the part-time way was really devastated to be missing your talk, so he gave me a question to ask you. He also gave me his email address, but I don't think that was related to you at all. No, he did say if we could email the answer, he'd be very interested, and he's a history student, but he just finds volcanoes fascinating. He said, could we create an artificial volcano to simulate the effects of global cooling?
Yes, that is a very good question, and that is a real question that has been discussed. So one thing I didn't talk about today, but when these gases get released very high up in the atmosphere, they can act as global cooling, similar to what Alan was talking about with the meteorites. And it has been seriously discussed. It's just it's a very dangerous thing to do. We don't know the chain reaction effects they could have. So before anything like that is done, it's not reversible. When we release that gas up there, we will not be able to take it back. So are we sure that that's going to have the effect we want to have? And who's going to have the hand on the thermostat? That's another question. Who's going to control? So it's just, as a mankind, we're just not ready for that kind of high-tech solution. We have to be careful with those.
I like that the solution was nuke it, just throw a bomb at it.
Exactly, yeah.
Just nuke
Put a funnel.
It'll be fine, it'll be fine. Why the interest? Is it because you grew up in Iceland? Did that inspire your interest in volcanoes, or do you just think it's really cool?
Yeah, well, because in the UK, volcanology is often seen as a kind of a slightly frivolous subject. They're like, that's not a practical subject, is it? But in Iceland, it's actually a very applied subject. So because in Iceland, for instance, 95% of domestic energy power comes not from wind or hydro, but from geothermal, so from volcanoes, essentially. So so geothermal energy is like our oil, but also you have all the hazards things. So it can give you huge benefits, but also kill you. So.
Worth it, probably worth it. We've got a question here just at the front. From Beetle Boy, yes, go ahead.
Thanks for that. How many people around the world are affected regularly by living with the volcanic gases?
I don't know. But basically because it's really understudied, and most volcanoes actually exist in developing countries where there's just very poor capabilities to monitor anything. We think that about 30 countries on the official development assistance list, so countries that UK is committed to assisting in development, may suffer from this. And if you couple that with the fact that 90% of premature deaths from air pollution are from developing countries, not just from volcanoes, but from other sources like indoor cooking and all kinds of things, it just shows that in the developing world, we really need to pay attention to both man-made sources, but also natural sources like volcanoes.
Do we have any other questions from the audience?
Can I ask one?
No, you're not allowed. You're
Okay.
simply
No,
here to hold the mic. Yes, go ahead.
Is it possible to accurately predict like a Krakatoa level eruption? Is that something we can predict accurately?
So predict the level of
Like
how big the
a
eruption
Krakatoa,
is.
you know, a Krakatoa eruption?
Oh,
like
yeah.
something of that size, is it possible to predict that?
So we cannot predict it like which day it's going to happen, but it's possible, like within some years of it happening, I would say we would have a pretty good idea that something big is going to blow. It's not going to come out of nowhere.
You know, in your line of work, you've been working with active volcanoes in Iceland and Hawaii, Latin America. You're telling us about the risks. Isn't that quite a dangerous thing to do? What do people who work with volcanoes do to kind of protect themselves whenever they're going into that? I mean, I wouldn't do it. So how do you how do you protect yourself whenever there's so many gases and things?
Very good question. You probably imagine people kind of wearing like
I'm imagining those suits, you know, whenever yeah, that's
things.
exactly what I'm thinking.
Well, actually, about, let's say, in the 80s or 90s, when Dante's Peak was made, I think per head count, volcanology was the most lethal profession. So more volcanologists died than people in the armed forces. Because pretty much every other volcanologist died. They had to climb into the volcano. Since then, we've luckily just had enough technological development to prevent people from having to climb down into the crater and do it themselves. So we have remote sensing, so we can point our instruments from far away. We can even use satellites to point at the volcanoes. And now, in the last, let's say, 5 years, what do we have? We have drones. So we can send them, and they can go and die, and that's fine. But but actually, I really rarely have to. I've never worn a full body suit. Most thing I've done is to wear a hard hat in case things fly out of the crater far away. I've never been hit on the head or anything like that. And a gas mask. You just keep it. But you never really come close enough to be in real physical danger from it. Yeah. Yeah. So it's just. Last 20 years have made volcanology a safe profession.
Yeah, so, but whenever you were going to study it, you were thinking, all these people have died, but sure, it'll be grand. Because I would be looking at that saying, too many people have died in that profession, not doing that, on to the next thing. That's fantastic, you're very brave. Do we have another question? We've one here and then a few down the back.
That was a great talk. Thank you very much for speaking. You mentioned that you sometimes wore gas masks whenever you were studying volcanoes. Is that ever implemented in the general public in Iceland to protect kids from toxic gases?
Yeah, that's a very good question. Actually, a slightly political one. So in Iceland, it didn't last long enough for gas masks to be issued to the public. In Hawaii in the summer, you may remember it made headlines because eruptions started up in a residential area, so loads of people were impacted. And people started to wanting to buy gas masks and didn't know which one is the correct one. And often, so gas masks are not very effective unless they're fitted quite like in a way that you know what you're doing, and they don't fit children. But if you wear them incorrectly, they can actually give you a false sense of confidence, and you may think you're fine and then be not fine. So you should not be in an area where you are at the level of needing a gas mask if you don't know what you're doing. So the kids in Iceland, I mean, they're dangerous, but the levels were dangerous, but they didn't probably last very long. And people could go inside. That's the best protection, I think, to summarize. Yeah, if you're in doubt, you should just go inside. At least in Iceland, where the houses are, you can close all doors and windows. Sorry? Yeah, exactly. So if houses are well built, same as there in the UK, you have pretty good air quality indoors compared to polluted areas outdoors.
Really interesting question, actually. 10 points for our first political question of the evening. Evgenia, we don't really talk much about politics here, so I think we had a question up at the back. Somebody raise their hand. Yes. Go ahead, please.
With the dragon fruit and the pineapple, is there any phylogenetic closeness between the two of them? Because if there was, you could actually probably find more fruits and other crops actually grow in that area then.
Yeah, exactly. I know absolutely nothing about plants other than the pineapple from Nicaragua is delicious. That's as far as my extended knowledge goes. Yeah, so I would love to talk to botanists and agricultural specialists who can give some ideas and take this forward. I think it's a great area of research. The farmers in the area, they tell us they think it's because the pineapple is somehow resistant to the acid rain, and then the acid rain kills the parasites on the leaves. I mean, they also don't really know, I don't think, for sure what the mechanism is.
Do we have any more questions? Okay, I will go with my last question. It's just whenever we were seeing that video from Living with Volcanic Gases, one of the ladies had said about, you know, the kind of dread whenever rainy season comes because the fumes are so much worse and it's so much noticeably worse. Why is there such a huge difference between the seasons that it's so noticeable to the people who live there?
That's one of the things we are working on at the moment. We don't know, that's the answer. We think because of what happens in the atmosphere, kind of the atmosphere is different in the winter. When it's raining, it's denser, so the smoke, instead of going straight up in the air, it kind of flows along the ground. It's to do with aerodynamics, essentially, during the winter.
Could we please give a massive round of applause to our last speaker, Evgenia? Thank you so much.